find positive numbers a such that x squared minus ax plus 4a equals 0 has only integer roots. This is the given quadratic equation. We let x1, x2 be the two integer roots. We assume x1 is greater than or equal to x2. By Vieta's formulas, x1 plus x2 equals a, x1, x2 equals 4a, as x1, x2 equals 4a, so we can now write x1, x2 equals 4 times x1 plus x2. By rearranging the equation, we can now write x1, x2 minus 4x1 minus 4x2 equals 0. The first two terms on the left-hand side of the equation can be factorized, so we can now write x1 times x2 minus 4. We also add 16 to both sides of the equation, so that minus 4x2 plus 16 also has a factor x2 minus 4, and we can now write minus 4 times x2 minus 4. So the left-hand side of the equation can now be written as x1 minus 4 times x2 minus 4, since a is greater than 0, and we know that x1, x2 equals 4a. So x1, x2 must both be greater than 0, or must be both less than 0. We also know that x1 plus x2 equals a, which is greater than 0. So x1 is greater than 0, x2 is greater than 0. So there are three cases: x1 minus 4 equals 16, x2 minus 4 equals 1, or x1 minus 4 equals 8, x2 minus 4 equals 2, or x1 minus 4 equals 4, x2 minus 4 equals 4. So x1 equals 20, x2 equals 5, or x1 equals 12, x2 equals 6, or x1 equals 8, x2 equals 8. Thus, a equals x1 plus x2, which is 25, or 18, or 16.